Hello. As they say, polyalkylation wants a cracker. All right, so here's the deal with amines. Because they are um, substances that contain lone pairs, they can act as nucleophiles in organic reactions. And a situation in which you treat ammonia with an alkyl halide, a pretty good SN2 substrate, you would think it should go pretty smoothly, right? And technically it does, because the attack onto the carbon by nitrogen happens, relatively well, and the cleavage of the methyl bromine bond takes place, thus forming methyl ammonium bromide in the process. Now, to get to the corresponding neutral product, what happens next is that you deprotonate your ammonium salt with some additional base that you have present in solution. So one ammonia molecule can easily come in and remove that proton. The electrons go back to nitrogen, and you end up with methylamine in the process. Now, if this was literally the end of the story, then this will be a pretty mundane reaction. Um, but unfortunately, the moment you have introduced that methyl group onto nitrogen, you have now turned the ammonia that you started with into a much better nucleophile. You have increased electron density on your nitrogen just because of having that methyl group in there. So what that means is that you're going to continue doing more nucleophilic reactions. So unfortunately, yes, that methylamine um, is going to go ahead and react with alkyl bromide that's present in solution still. So you will have that nucleophilic attack taking place, breaking the carbon bromine bond, and now forming dimethyl ammonium bromide. That also will get deprotonated. Um, and in the process, now you end up with dimethylamine. Now, here's the problem with this situation. Let's make the argument that what you were trying to make was just methylamine. You just wanted to make that primary amine product and stop right then and there. If you were to just try to make that amine doing SN2 reactions, you're basically done for. Like you will not get a good yield, and not only that, but you will also end up with these polyalkylated byproducts, and then you have to separate all these things from each other, which is not a trivial thing. Separation of amines is, it's doable, but it's painful. It's yeah, it's difficult. It's absolutely difficult. So this is not a great uh, starting sequence to occur. And the same thing goes for the other ones, right? Because let's say maybe you wanted to make dimethylamine at the end of the process. Well, you're still going to end up with trialkylated, tetraalkylated, some monoalkylated product, and some ammonia that didn't even react. So it's just a mess all the way around. And then this thing here with the two methyls, if one methyl was, good for enhancing the nucleophilicity, well, two are also, uh, a better off situation for your nucleophile. So that dialkylamine can easily react with carbon, the carbon of your methyl bromide substrate, breaking that carbon bromine bonds and forming now trimethyl ammonium bromide. That also undergoes deprotonation, which is base that's around, and you end up with trimethyl amine. So yeah, this polyalkylation is just gonna keep happening, and the problem here is that it doesn't matter if you go very diligently with your quantities. Like if you only have one equivalent of ammonia, one equivalent of alkyl bromide, well, technically, you have to be two equivalents of ammonia because you need the deprotonation to happen. But yeah, this will just give you a mixture of a bunch of stuff: unreacted ammonia, methylamine, dimethylamine, trimethylamine, and not only that, but then this thing can even react further with alkyl bromide and give you the tetraalkylated derivative, so tetramethyl ammonium bromide. And then this one doesn't have any protons here, so there's no deprotonation that happens. So you're pretty much done at that point. Like this will be the end point, but you have this cascade of reactions that makes the synthesis of primary amines or secondary amines or tertiary amines via a straight out SN2 reaction completely useless. So what I'm going to do is I'm going to show you a number of reactions that are going to allow you to exclusively get to the primary amine or go to the secondary amine or go to the tertiary amine very efficiently. Um, and so the next set of videos will pretty much deal with that. And I want to have a video for each one of these reactions. So I'm going to stop this video, and it's a little bit short, but I'm going to stop this video right here, and I will catch you on the next one where we start talking about amine synthesis, specifically the Gabriel synthesis. So see you then. Bye bye.